In this video, we will briefly discuss what Numpy is, how to install it on your computer, and some general concepts. Numpy is a linear algebra library for Python. The reason it is so important for data science with Python is that almost all libraries in PyData rely on it as one of their main building blocks. It is also incredibly fast. After installing Anaconda, as we did in previous section, go to your terminal and type conda install numpy. Now let's go to Numpy. Numpy arrays are the main way we will use them. The arrays come in two forms, vectors and matrices. Vectors are 1D arrays and matrices are 2D. But remember, a matrix can also have one column and a row. Now we are going to talk about NumPy arrays and how to use them. Let's have a look at how we can create a NumPy array from a Python list. At first, let's import NumPy. Import NumPy SNP. And then let's create a Python list. My list equals brackets 0, 1, and 2, for example. And then we can call np.array parentheses and my list as an argument. And here is the result, array 0, 1, and 2. We can also assign it to a variable and again call it. For example, my array equals np.array my list and print my array. This is one-dimensional array. And if we want, let's say, two-dimensional array, we can write. At first, we can create a list, brackets, and then another brackets, 0, 1, and 2, 3, 4, and 5. Notice we have created a list of lists. Now we can return an array by writing array2 equals np.array parentheses and list2 as an argument. Print array2. Now it has 2 rows and 3 columns. 2 rows, 0, 1, and 2. And the second row, 3, 4, and 5. You can also create an array by generating them. For example, np.arrange parentheses 0, 10. Start point 0 and end point 10. Here it will return an array of numbers from 0 to 10, but not including 10. So we have here 10 numbers from 0 to 9, 9 including. Here you can also add a step size. For example, we can add here 2. And then we will get only even numbers from 0 to 10, but not including 10. Do not forget it. If you want to include 10 also, you should write the second number, the endpoint 11, and then we can hit run, and then we will get all even numbers from 0 to 10. Now, if you want to generate an array of all zeros, you can write np.zeros, and let's say 5 of them. And we have an array of 5 zeros. Or you can write a tuple of numbers from which the first one is the number of rows and the second one is the number of columns. np.zeros. Do not forget the second parenthesis for a tuple. And let's say 3 and 3. Or if you want an array of ones, you can write np.ones and let's say 7. Or again, you can pass a tuple and get a multi-dimensional array. np.ones. Do not forget again the parentheses and let's say 2 and 3. So we have 2 rows and 3 columns of ones. Now let's have a look at Linspace. It has the same start and end points as arrange, but here the third argument is the quantity of numbers returned. For example, here we want, for example, 5 numbers in an interval of 0 and 3. np.linspace. From 0 to 3, we want 5 numbers. And here are they. Or let's change it to 10. We want 10 numbers from the interval 0 and 3. It returns again a one-dimensional array, although it looks like 2 or 3, for example, 2 rows or 3 rows, but it is a one-dimensional array. Now let's create an identity matrix, np.I, and let's say 5. An identity matrix is a square matrix where the points on the diagonal are ones and the others are zeros. Numpy also gives an opportunity to create random numbers. We can write np.random, and this random has lots of different functions. So let's use some of them. At first, let's use np.random.rand, and let's say 5. This will return a one-dimensional array with a given number of points evenly distributed between 0 and 1. If you want two-dimensional, you can simply pass two numbers here in the parentheses. For example, let's pass 3 and 3. Here we don't pass tuple as we did above, just numbers. And here we have two-dimensional array with 3 rows and 3 columns. If you want to return a sample from normal distribution or Gaussian distribution, you just need to write np.random.randn, and in parentheses, let's say 2, which will return given numbers of a normal distribution centered around 0. And again, if you want two-dimensional, you can pass two numbers here. np.random.randn, let's say 3 and 3. If you want to get random integers numbers, you should write np.random.randint, and in the parentheses, for example, 1, 50, 20. Here, the first number is the smallest, which is inclusive. The second number is the highest, but not inclusive. And the third one is quantity. So we have some numbers, 20 numbers in the interval from 1 to 50. Now let's discuss some useful attributes and methods of an array. Let's create two new arrays. First one is an array from 0 to 15. Array 1 equals np arrange and 15. And the second one is an array of 10 random integers from 0 to 30. Array 2 equals np random.randint from 0 to 30, 10 numbers. One of the most useful methods is the reshape method, which shows the same array in a new shape. For example, let's run this. For example, we want to change the dimension of array 1. Let's have a look at first at array 1. It is a one-dimensional array. Now we want to reshape it. We can write array 1.reshape, and then in parentheses, let's say 3 and 5. And we have now two-dimensional array with 3 rows and 5 columns. Here the array 1 has 15 elements, so we can make it 3 by 5 array. Remember that you will get an error if you cannot fill that matrix. For example, if we write here 5 by 5, so we will get an error. So the multiplication of these two numbers should be equal to the number of array elements. Now let's have a look at methods that will help to find maximum and minimum numbers. Let's find the maximum value of array 2. Let's have a look at array 2. Here is it. It's a one-dimensional array. Now array 2 dot max 21, and minimum value will be array 2 dot min. And do not forget also the parentheses. So it is 3. And if you want to find the index locations of max and min elements, you can write array 2 dot arg max and array 2 dot arg min. And let's check it. So maximum number was 21 and the index is 0. Yeah, it's correct. And then array 2 minimum number was 3 here. And the index is 7. So 0, 1, 2, 3, 4, 5, 6, 7. So it's quite true. If you want to find the shape of an array, you can write, for example, the shape of array 1 and without parentheses. So it is a one-dimensional array with 15 elements. You can also find the data type of the array. For example, array2.dtype and without parentheses. So the elements are integers. That's it for this time. Thanks a lot for watching, and do not forget to subscribe for more videos.